Hello guys, welcome to another video of CSAT with Jasin. So in this video we'll be discussing about remainder theorem. And if you like the video, please do subscribe, share and support. So let's start with the video. So firstly, we need to look into what is a remainder, right? So a remainder is something that is left over after performing a division. So everyone knows what divisions are, right? So we'll take an example. If you need to divide 75 by 4, you will perform the division like this, right? You will take 75 here, then you will perform the division. So 4 into 1 is 4, then you will get 3a, then you will take 5 here, then 4 into 8 is 32, then you will get 3 here, right? So in this way, here 3 is called the remainder. So this is the remainder, this is the quotient, this is the divisor, and this is the dividend. So we can write dividend is equal to quotient multiplied by divisor into plus remainder, right? So here when you divided 75 by 4, you got remainder as 3. So this is the basic concept of remainder theorem, to find out a remainder when something is divided by another number. Okay, so here you need to also learn about another concept, which is the concept of negative remainder. So in the previous example, when you divided 75 by 4, you got remainder as 3. So here in this case, the negative remainder is equal to actual remainder minus divisor. So here in this case, negative remainder is equal to 3 minus 4, which is equal to minus 1. So you need this concept of negative remainder in solving various problems related to remainder theorem. So that's why you need to learn about negative remainder. Okay, so now we'll be moving on to the remainder theorems of various numbers. So first we will look into remainder theorem for 2. So what is the remainder theorem for 2? It's very easy. So if an even number is divided by 2, the remainder is 0. If an odd number is divided by 2, the remainder is 1. For example, if you take a number 345, this is an odd number. So if you divide 345 by 2, you will get remainder is equal to 1. Similarly, if you divide 248 divided by 2, which is an even number, you will get remainder as 0. So now we will look into the remainder theorem for 3. So remainder theorem for 3 is similar to the divisibility rule of 3. So divisibility rule of 3 states that a number is divisible by 3 if the sum of the digits of that number is also divisible by 3. Similarly, if you want to find out the remainder when a number is divided by 3, first you need to find the sum of the digits of that number, and then you need to subtract the closest multiple of 3 from that number. Okay, so I'll explain this to you with the help of an example. So let's take the example of 368. So you need to find out the remainder when 368 is divided by 3. For that, first you need to take the sum of the digits, that is 3 plus 6 plus 8. So you will get 3 plus 6 plus 8 is equal to 9 plus 8 is equal to 17. Now from 17, you need to subtract the closest multiple of 3. So closest multiple of 3 is 15, right? So from 17, the closest multiple of 3 is 15, which is less than 17. Okay, so 17 minus 15 is equal to 2. So the remainder when 368 is divided by 3 is 2. And here the negative remainder is minus 1. Okay, I am telling you about the negative remainder in this example as well, because you need to understand the concept of negative remainder, because it is going to help you in solving some questions. Okay. Now there is another way, simplest way to find out the remainder for 3. For example, if you are getting a bigger number like 4, 5, 6, 7, 8, 3 divided by 3. Now you need to find out the find out the remainder when this big number is divided by 3. For that, what you need to do is you need to cancel out the multiples of 3 from this number. That is, you can cancel this 3 because this 3 is divisible by 3, right? You can cancel this one. You can cancel 6. And if you add 5 and 7, you will get 12. 12 is a multiple of 3. So you can cancel 5 and 7 together. So if you now when 8 and 4 is added, you will get 12, right? So you can cancel that as well. Now remaining number is 2. So remaining number is 2 means now which is the closest remainder for 3 from 2 is 0, right? So 2 minus 0 is 2. So the remainder will be 2. If this number is divided by 3, the remainder will be 2. So you don't need to take the sum of the digits. You can cancel out the multiples of 3. That is also another way. I will explain this with another example as well. So for example, you take 5, 1, 1, 5, 7, 8, 1 divided by 3. Okay. So in this case, 5 plus 1 is 6, which is divisible by 3. So you can cancel it out. 1 plus 5 is again 6, which you can cancel out. 7 plus 8 is 15, which is again a multiple of 3, you can cancel out. So remaining is 1. So remainder when this number is divided by 3 will be 1. Okay, so this is the remainder theorem for 3. Now we will move on to the remainder theorem for 4. Again, this is similar to the divisibility rule of 4. So a number is divisible by 4 if the last 2 digits of that number is divisible by 4. So if you are getting a question like, for an example, we'll take 4, 5, 6, 7, 8, 3, 2, 3 divided by 4. So you need to find out the remainder when this number is divided by 4. For that, you just need to take the last 2 digits. So you just need to find out what is the remainder when 23 is divided by 4. So for that, we can subtract the closest multiple of 4 from 23, that is 20. So you will get 3. So when this number is divided by 4, the remainder is 3. This is the remainder theorem for 4. Now we will go on to the remainder theorem for 5. This is very easy actually. So if you get a number, if the last digits of each of that number is greater than 5, then you need to subtract 5 from it to get the remainder. If that number, if the last digit of that number is less than 5, you need to minus 0 from it. For example, you have a number like 3, 2, 3, 4, 2 divided by 5. You need to find out the remainder when this number is divided by 5. What you need to do is you need to this 2 is less than 5, right? Last digit 2 is less than 5. So the remainder will be that number itself. So remainder is equal to 2. So if 4, 2, 7, 8, 9 is divided by 5, the last digit is 9, which is greater than 5. Then the remainder will be 9 minus 5, which is equal to 4. Okay. Now for 6 and 7, there is no standard rule for remainder theorem. So we'll move on to remainder for 8. So for remainder for 8, what you need to do is take the last 3 digits. So we have studied the divisibility rule of 8, right? So divisibility rule of 8 is like, if a number is divisible by 8 if the last 3 digits of that number is divisible by 8. So here I'll give you an example. So let's take an example. 4, 5, 6, 7, 8, 3, 2, 3 divided by 8. So here last 3 digit number is 323. Right. So we need to check the remainder when 323 is divided by 8. So we know that 320 is divided by 8, right? So 320 means 8 into 40 is 320. So the remainder here will be 323 minus 320, which is equal to 3. And what will be the negative remainder? The negative remainder will be 3 minus h, which is equal to minus 5. Okay. This is the divisibility rule of 8. Remainder theorem for 8. Now we will move on to the remainder theorem for 9, which is similar to that of 3. So for that, you need to take the sum of the digits and then you need to subtract the closest multiple of 9 from that number. Okay. So again, I will take the same example. We need to find 4, 5, 6, 7, 8, 3, 2, 3 divided by 9. Here similar to what we have done with 3, you can cancel out the multiples of 9. Okay, so here 4 plus 5 is 9, so you can cancel it out. Then 7 plus 8 is 15, 15 plus 3 is 18, which is a multiple of 9, so you can cancel that out. Now 6 plus 3 is 9, so you can cancel it out. So remaining is 2, so the remainder for 9 is 2. When this number is divided by 9 is 2. Okay. So we'll take another example like 368 divided by 9. So another method is like just add the digits, that is 3 plus 6 plus 8. You will get 917. So now you need to subtract the closest multiple of 9 which is less than 17. That is 17 minus 9, right? So you will get 8 as remainder. Also, if you use this cancellation method, we can see here that 3 plus 6 is 9, right? So you can cancel it out. So remainder is 8. So similarly, we got the remainder as 8. So these are the remainder theorems for various numbers. Now we will be moving on to the remainder theorem when we are doing summations, multiplications, combinations of sum and multiplications, etc. So now we will learn about the remainder theorem during summation. Okay, so let's say we have a question like what is the remainder when 31 plus 28 plus 30 plus 33 is divided by 3. So let's say this is the question. So in this case, what you have to do is that you need to calculate the remainder separately and then you can add. That is, when 31 is divided by 3, you will get a remainder as 1. When 28 is divided by 3, you will get the remainder as 1, right? Because 27 is divisible by 3. Now 30 is exactly divisible by 3, so remainder is 0, and 33 is also exactly divisible by 3, so remainder is 0. So now the remainder of this function is 1 plus 1 plus 0 plus 0, which is equal to 2. Okay, so similarly, this is the same thing in subtraction as well. Okay, for example, you have been asked like what is the remainder when 34 minus 29 is divided by 7. Now you need to find out what is the remainder when 34 is divided by 7. What is it? It will be 6. So that is 28 is divisible by 7. So 34 minus 28 is 6. Now when 29 is divided by 7, the remainder is 1. So the remainder when this operation is done, 6 minus 1 is equal to 5. Now I'll give you another example. That is, let's say we need to find out the remainder when 29 minus 13 is divided by 7. So when 29 is divided by 7, you will get remainder as 1, and 13 is divided by 7, you will get remainder as 6. So that is 1 minus 6 equal to minus 5. Right. So minus 5 here we got a negative remainder. That is, this is the negative remainder. So to find out the positive remainder, you need to add 7 to it. That is 7 minus 5, that is 2. Okay, so another I'll give you one more example. That is, we need to find out the remainder when 32 plus 35 plus 28 is divided by 6. So when 32 is divided by 6, you will get 2 as remainder. When 35 is divided by 6, you will get 5 as remainder. And when 28 is divided by 6, you will get 3 as remainder. So the remainder here is 2 plus 5 plus 3, which is equal to 11. But the remainder will always be less than the divisor, right? So 11 is greater than 6. So you need to subtract 6 from 11. So answer is actually 5. So 5 is the remainder. Okay, so this is the remainder theorem during summation. Now we have to check the remainder theorem during multiplication. So similarly to summation, you can take the remainders separately and then you can multiply it. For example, let's say 22 into 22 into 2 into 22 into 22 divided by 7. So you need to find the remainder. So when 22 is divided by 7, remainder is 1. Again 22 is divided by 7, remainder is 1. 2 is divided by 7, remainder is 2. Then 22 is divided by 7, remainder is 1. So you will get 1 into 1 into 2 into 1, which is equal to 2. So when this operation is carried out, the remainder is 2. So similarly, if you have a question like if you have a question like 22 raised to 6000 divided by 7, what is the remainder? So that is actually 22 into 22 into 22, like that, 6000 times divided by 7, right? So when 22 is divided by 7, remainder is 1. When 22 again is remainder by 7, remainder is 1. So this is like remainder is 1 raised to 6000, right? So which is 1. Okay. So in case of remainder theorem during multiplication, the negative remainder also comes into play. Sometimes doing with the negative remainder is actually easy. Okay. For example, let's say 76 into 16 divided by 7. You need to calculate the remainder. So either you can write the remainder when 76 divided by 7 as 6, or you can write it as minus 1, because negative remainder here is minus 1, right? So here again, when 16 is divided by 7, your remainder is 2. Either you can write it as 2 or you can write it as minus 5, right? So here remainder you can take it as minus 1 into 2. So I am taking the smallest numbers, so that multiplication is easy. So in these cases, this is a small question, then even if you take this number, it is okay. But if you get a very big question, taking the smallest number will be easy for you to do the calculations. So that's where negative remainder comes into play. So here remainder is equal to minus 2, right? So this is the negative remainder. So actual remainder is 7 minus 2, which is equal to 5. Okay, so even if you take this number, that is, even if you take 6 and 5, you will get, 6 and 2, you will get 6 into 2 is equal to 12. So then you need to subtract 7 from 12. So 12 minus 7 is equal to 5. 5 is the remainder. So even if you do in either way, you will get the remainder as same. But if you take the smallest number, whether it is negative remainder or the actual remainder, your calculations are going to be very easy. Okay, so I will give you another example so that you will understand the importance of negative remainder. Okay, that is, let's say 1327 into 1325 into 38 into 66 divided by 13. So you need to find out the remainder. You know that 1326 is exactly divided by 13, right? So 13 is 13 into 1 and 26 is 13 into 2. Therefore 1326 is exactly divided by 13. So when 1327 is divided by 13, the remainder will be 1. Similarly, when 1325 is divided by 13, the remainder will be 12, right? Or you can take it as minus 1. Okay, you can take it as minus 1. And here you can again take it as minus 1 because it is 13 into 2 is 26. So 38 minus 26 is equal to 12. The remainder is 12. Or you can take it as minus 1. Okay. And 66 when divided by 13, you will get remainder as 1 because 65 is divisible by 13. So here the remainder is 1 into minus 1 into minus 1 into 1, which is equal to 1. So see, you got the remainder easily. If you are taking the positive remainders, here you will get 1, here you will get 1, here you will get 12, here again you will get 12, here again you will get 1. So you need to calculate 1 into 12 into 12 into 1, right? Then you will get a bigger number, then you need to again divide that number by 13. So that is very difficult. So that's why taking the smallest number, either it is the negative remainder or the positive remainder, is easy for you. Okay. Now we will look into the combination of both multiplication and division. Multiplication and addition. So we'll take an example like 34 into 26 plus 31 into 39 divided by 7. Here also it is similar. What you need to do is you need to do that separately. So 34 divided by 7, you will get remainder as 6. 26 divided by 7, you will get remainder as 5. Here 31 divided by 7, you will get remainder as 3. Right? When 39 is divided by 7, you will get remainder as 4. That is 6 into 5 plus 3 into 4. So you will get 30 plus 3 into 4 is 12. So you will get 42. So 42 is exactly divisible by 7, right? So remainder is equal to 0. So this is how you need to do the combination. Now one more thing is there, that is the remainder theorem during cancellation. That means if you cancel a fraction into a smaller one, if you cancel common factors into and get the smaller version of a fraction, then how we need to find out the remainder. Okay, so let's take the example 3396 divided by 42. So in both 3396 and 42, 2 is a common factor, so I am cancelling 2 from both this. Okay, so by cancelling 2 we will get here 1, 6, 9, 8, right? And here you cancel, you will get 21. So this is equal to 1698 by 21. We cancelled 2 here. Okay. Now again, if you see 2 plus 1 is 3, 1 plus 6 is 7, plus 9 is 16, plus 8 is 24. So this is also, this both 1698 and 21 is divisible by 3, right? So here if you divide it by 3, you will get 566, and here if you divide it by 3, you will get 7. So this is same as 566 by 7. So here we cancelled 3. So now you need to find out the remainder when 566 is divided by 7. Okay, so what is 566 divided by 7? 749, right? 76. So if 7 into 8 is 56. So that is 0 and 6. So 6 is the remainder. Okay, 6 is the remainder. So you got 6 as remainder. But you have already cancelled 2 and 3 here. So actual remainder is, from this remainder you need to multiply 2 and 3. So actual remainder will become 36. Okay. Now we will look into the remainder theorem of powers. Okay, that is, for example, I will give you some examples and explain this to you. Let's say we have a question like 31 raised to 6365 divided by 6. Now here what you need to do is, if you divide 31 by 6, you will get remainder as 1. So this is similar to 1 raised to 6365. Okay, so 1 raised to 6365, the remainder will be 1. Okay. Another thing, if you got a number like 29 raised to 1258 divided by 6, here 29 when divided by 6, you will get a remainder 5, or you can also write it as negative remainder, that is minus 1, right? When 29 divided by 6, the negative remainder is minus 1. So minus 1 raised to 1258, which is equal to 1. So here also the remainder is 1. Okay. So I will give you another example. Let's take another example, that is 629 raised to 2567 divided by 9. So we know that 630 is divisible by 9, right? 630 divided by 9 is 70. So 630 is divisible by 9. So 629 raised to 256 divided by 9 means 1 minus 1 raised to 256. So that is equal to 1. So the remainder is 1. See, so in these cases, the negative remainder is coming into play. So that is why the negative remainder is so important. Okay. So in solving in these kind of questions, it's very important. Now we will take another example. Let's say 9 raised to 10 divided by 7. So I can write it as 9 divided by 7, you will get a remainder as 2. So this is similar to 2 raised to 10 divided by 7. So when the remainder, when 9 raised to 10 divided by 7 and 2 raised to 10 divided by 7 will be same. So I am taking 2 raised to 10 divided by 7. So that is 2 cube into 2 cube into 2 cube into 2 divided by 7. Right, 2 cube is 8. 8 when divided by 7, you will get remainder 1. Here also you will get remainder 1. Here also 1. Here 2. So the answer is 1 into 1 into 1 into 2, which is equal to 2. So in this way you can find out the remainder. So now let's consider some examples. So first is if 3 raised to 2019 is divided by 10, then what is the remainder? Okay, so we have to write 3 raised to 2019 into different form. So let's write it as 3 raised to 4 whole raised to 504 into 3 cube. Because 3 raised to 4 whole raised to 504 is actually is equal to 3 raised to 4 into 504. So 504 into 4 is 16, 4 into 5, 20, 2016. Okay, so why I written 3 raised to 4? Because 3 raised to 4 is actually 81. If 81 is divided by 10, then you will get remainder 1. So using, since we'll get remainder 1, the calculations are actually very easy. That's why I have written like this. So if the denominator is 10, you should try to make the numerator as 81. Then the calculations will be easy. So here it will be like 81 raised to 504 into 27 divided by 10. So this is similar to 1 raised to 504 into, if 27 divided by 10, the remainder is 7. So answer is 7. Now we will take another example. Here, what is the remainder when 51 into 27 into 35 into 62 into 75 is divided by 100? So here we have to use the method of cancellation, that is 51 into 27 into 35 into 62 into 75 divided by 100. So here in 75 and 100 the common factor is 25. So I am cancelling with 25. You will get 3 here and you will get 4 here. So we cancelled with 25. Okay, so when 51 is divided by 4, the remainder is 3. Or you can write it as minus 1 because negative remainder is minus 1. Similarly, when 27 is divided by 4, you will again get remainder as 3 and the negative remainder as minus 1. When 35 is divided by 4, again the remainder is 3 and negative remainder is minus 1. And when 62 is divided by 4, you will get remainder as 2. And when 3 is divided by 4, you will get remainder as 3, or you will get negative remainder as minus 1. So the remainder is minus 1 into minus 1 into minus 1 into 2 into minus 1, which is equal to 2. Okay, but here since you have cancelled with 25 initially, you need to multiply 25 with 2 to get the actual remainder. So actual remainder is 2 into 25, which is equal to 50. So option A is the right answer. Now we will look into another example. The number 8745962A gives remainder 1 when divided by 4. How many values of A are possible? So what is the remainder theorem for 4? So we need to take the last 2 digits. Here last 2 digits is 2A. So when 2A is divided by 4, you will get remainder as 1. Then A will be either it will be 1, right? Because when A is 1, it is 21. So 21 divided by 4 is remainder will get as 1. A is equal to 5 is also a possibility, because when 25 is divided by 4, you will get remainder 1. Then A equal to 9 is also a possibility, right? Because 29 divided by 4 is also, we will get remainder as 1. So 1, 5, 9 are possibilities. So there are 3 possibilities. So answer is option C, 3. So that's all with the remainder theorem video. So if you like the video, please do share, support and subscribe. Thank you.